Welcome to InfoGrades. InfoGrades is bringing you all that you need to excel in your studies, specifically in the subjects of chemistry and biology, all levels, AP and IB subjects, other competitive exams, and all other elementary subjects too. A lot of educational content is coming up on this channel, so make sure you do subscribe, share, like, or any way you can support this channel for yourself and for your loved ones. So let's start today's video. Today's topic is fundamentals of periodic table. This chart that you see here, this is modern periodic table that arranges total of 118 elements discovered so far in order of an increasing atomic number. So if you see hydrogen atomic number 1, so see here in the left corner, this 1, that means atomic number. Helium atomic number 2, lithium atomic number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So continuously all the way we have it up to 118. So these elements, they are arranged in an order of increasing atomic number. So this is the principle of modern periodic table. So the periodic tables that have been used previously in history, so they were based on the atomic masses. But because we don't see a regular pattern in the atomic masses, so that's not a very useful method. So now we are using this modern periodic table that is based on the increasing atomic numbers. Other than that, if you might have noticed so far, so we see continuous increase in a certain way, increase in the atomic number in a certain way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So likewise. So that means if we go from left to right, so we see a continuous increase in atomic number. So these horizontal rows are called as periods in the periodic table. Periods. We see continuous increase in the atomic numbers in the period. So total, there are 7 periods in total. So period, so if we label them 1, 2, 3, 4, 5, 6, and 7. So we go from left towards right in a period. So these two bottom rows that we see down here, so these are not separate periods. We don't count them as 8 and 9 because these are continuation of these previous. We see this lanthanum, atomic number 57, right? From 57, and next we see is 72. So where are those 14 elements? So they are here in this series. All right. So 58 all the way up to 71. So this series that we see here, that's a continuation of lanthanum, is called as lanthanide series. I will be explaining it more in the next videos, next slides. So lanthanides. So the second bottom series that we see here down, so that is starting from thorium, atomic number 90, that's a continuation from actinium. Actinium is 89. So you see the next 90, 91, 92, all the way up to 103 lawrencium here. This series is continuation of actinium. So that's why this series, the bottom last series, is called as actinides. So these are not separate periods. Other than that, very important thing, if you might have noticed, is there are some elements in vertical columns. So if you see, this is first vertical column, second vertical column, third vertical column, fourth, fifth, sixth, likewise. So these standing columns, these are called as groups. So total, if you can see, there are 18 groups. All right. So this way, if we go, these are called as periods. So if we go from left to right, if we go from top to bottom, these are called as groups. So how many groups are there in total? 18. How many periods are there in total? 7. All right. Groups are also called as family or also called as column. Why they are called as family? Because like as family members, they share some similar traits, some likes, dislikes, some culture. Same way, the members in one group, all the chemical elements in one group or the members of one group, they will share similar chemical properties. They will show very similar chemical reactions. They will all share same valency. So you see this positive charges here. That means a valency. This means they all are having positive 1 charges. Second group all are having positive 2 charges, like that. So what is valency? If you're not sure, we will be discussing that in the next video. So I will provide a link. So make sure you do watch that. So valency is the charges, right? So you see here, combining capacity of the element is called as valency. So you see all these. So these are called as groups. So groups or families or columns, those are vertical columns and they do share similar chemical properties. All right. When we see in the periodic table, so another important thing is, so all the symbols are written here, right? So we see all the symbols. Whenever we write chemical symbol, we write first letter in uppercase, right? You see all of them. So beryllium B capital, magnesium M capital, calcium C capital, strontium S capital. Second letter is always small, first letter is always uppercase. So symbol in the center, atomic number on the top, atomic mass at the bottom, and the charges on the top right corner. So for all of them, you see the similar behavior. So for all these elements, you see for beryllium, for example, beryllium is the symbol Be, 4 is atomic number, name is beryllium, mass is 9, charge is 2 positive. All right. So these are some important features. So let's talk about some other important features and summarize it what we have done so far. So let's summarize what we have done so far. The periodic law, the modern periodic law states that physical and chemical properties of the elements, they recur periodically, means they repeat themselves when the elements are arranged from lowest to highest atomic number. As I explained, so when we go from left to right in the periodic table and then we come back to the same group, so we see the element, whichever element is present in the same group, they do show similar behaviors, similar chemical reactions, similar valency, same valency actually. And if we go from left to right, so then the elements from left to right, they do follow some patterns. They do show some trends. They don't show same behavior. They don't have same they don't have same valency. They don't have same size, but they do have some patterns or some trends that we will be discussing in some other videos. All right. So as far as the broader classification is concerned, we have already discussed that the periodic table is divided into 2 main categories, groups and periods. Groups are the set of the elements in given column going down the table. Elements in the same group, they do share similar properties, and there are a total of 18 groups in the periodic table. Periods is a set of elements in a given row that are going across the periodic table from left to right. Total 7 periods in the periodic table. All right. So as I've already explained, so you can just review again one more time, pause the video and see if you understand. Okay, so if all good, so we can move on to some other major classifications of the periodic table. So first thing first, as I said, we have different columns, like total of 18 groups in the periodic table. So some of them, they're very important. So they are used more in chemical formulas, in the reactions. So you will see they're used more. So we have separated them, or they do show some very distinguished behavior. So we have named some of the groups that you need to know. First of all is alkali metals. So group 1 elements are called as alkali metals. So they're the strongest metals in the periodic table. Alkaline earth metals will be the group 2 elements. Halogens are group 17. Noble gases are group 18 elements. Representative elements are group 1, 2, and 13 to 18. Transition elements are group 3 to 12. Lanthanides are the bottom first series I have shown you, that is continuation from lanthanum and to lutetium. Actinides, they are the very bottom series onto the periodic table. All right, because it follows from the actiniums, it's called as actinides. All right, so moving forward, elements can be further divided into three major groups: metals, nonmetals, and metalloids. Metals are located on the left side of the periodic table. So the elements on the left side of the periodic table called as metals. Metals are shiny, they are malleable, they're ductile, they're good conductors of electricity and heat. So nothing surprising. Of course, metals are used in the electrical appliances. Metals are used to cook. So of course, they are good conductor of heat. That's why we use them to cook. Metals are good conductor of electricity. That's why we use them in electrical appliances for wiring, right? So metals are malleable. So what does malleable mean? Malleable means that they can be hammered into thin sheets. So if you hammer them, so instead of breaking down, they convert into thin sheets like aluminum foil, gold foil, silver foil, so many other metals like tin, um, iron, copper. They can be hammered into thin sheets. Other important property of the metals is ductility. They are ductile. Ductile means they can be stretched into wires. So they can be stretched into wires. Like, gold jewelry uses gold wires, silver in jewelry, copper wire in electricity. So there are so many different uses of course, both of these properties. They're very useful properties of metals. Other than that, very important thing about metals is they lose electrons. So metals are the ones that lose electrons. They make cations. I have explained what the cations are in my other videos, so do make sure you watch that. Cations and anions, they are important for the formation of the um, ionic compounds. So metals form cations. All right. Some examples, there are tons of examples from the periodic table: sodium, copper, gold, iron, tin, zinc. So they are all the metals. Other important category we have is the nonmetals. Nonmetals are present on the right side of the periodic table, but make sure we don't include these group 18 called as noble gases. So these are not nonmetals. So nonmetals include from group 13, from group 17, but group 13 is actually not a nonmetal completely because it does show the properties between the metals and the nonmetals. So the elements that show the properties intermediate between the metals and the nonmetals are called as metalloids. So this is metalloid. So how do we identify metalloids? Metalloids are the elements that you see here on this staircase, if I am trying to highlight these. So boron, silicon, aluminum, germanium, arsenic, antimony, tellurium, polonium, astatine. But sorry, that's not this aluminum. Yeah. So these are the elements that are considered as metalloids. So metalloids do show the properties between metals. So metals, where are metals? So metals are on the left side of the periodic table. So all these are metals. Non-metals are on the right side of the periodic table, excluding the group 18 elements. So non-metals, they usually exist as, like if we highlight non-metals, so non-metals usually exist as, all these are non-metals. So they exist as mostly liquids, or sorry, the gases or the liquids. But not limited to that. As I always say, chemistry is full of exceptions. Carbon is one known non-metal that stays as the hardest known substance. It exists as diamond. That is still a non-metal, but one of the hardest substance known. So, but mostly the non-metals, they do exist as gases or liquids at room temperature. Iodine exists as solid at room temperature, soft solid, right? But some of them, they do exist as, most of them, they do exist as gases like nitrogen, oxygen, fluorine, they do exist as gases, right? Some of them they do exist as liquid at room temperature like bromine. So the non-metals, they are dull, they are brittle, they are poor conductor of electricity, and they do gain electrons. So the non-metals make anions. So metals lose electrons and they make cations. Non-metals gain electrons and they make anions. So I have covered that already in another video. So other important thing that you need to go over here is that the metallic character increases as we go from left to right. Sorry, decreases. So metallic character decreases from left to right. So the metals or the elements that are on the left side of the periodic table, they will be the strongest metal. So if I talk about, let's say, the period 2. So in the second period, so lithium will be the strongest metal. Then comes beryllium, then boron, and then after slowly we see the metallic character decreases, and after carbon onwards, they are non-metals only, right? So neon is a noble gas. So that's how we can divide the metals, non-metals, and metalloids. So let's quickly summarize what we have done so far. Okay, so we have already done periodic table, the vertical columns are called as groups, right? The standing ones, groups. The rows that are laying down, periods. Total of 7 periods, total of 18 groups. Other than that, we have divided the periodic table into 3 major categories already. Metals on the left side, non-metals on the right sides, and these staircase elements that we have already discussed: boron, silicon, germanium, arsenic, antimony, tellurium, polonium, astatine. These are the metalloids. The elements on the right side are non-metals. Group-wise classification we have done some of the very important group. Group 1, alkali metals. Group 2, we have done that, alkaline earth metals. Group 3 to 12 are called as transition metals. The bottom 2 rows that we have already discussed, they are called as lanthanides. The first series we said that, lanthanides. Last series, this one is called as actinides. Group 17, as we said, it's called as halogen. Group 17, halogens. Group 18 are noble gases. And other than that, we also know that group 1, 2, 13, 14, 15, 16, 17, and 18 are collectively called as representative elements. So group 1, 2, and 13 to 18 altogether. All right. So that was a quick summary of all the periodic table, a major classification. So if you have Any other questions, or if you want me to make any specific video on any topic, so make sure you do comment down below. So I'll try to make it as soon as possible and post it for you. So if you like the content, so make sure you do subscribe, share, like, and support the channel as much as you can, and stay tuned for the upcoming courses. All right, thank you so much. Take care.